Welcome to Get Your FRQ On. This question is from 2026. It is question 2, and it is calculator active. In the question stem, we have two functions, f of x, which is an exponential function, and g of x, which is a rational function, and we are provided with two different graphs featuring combinations of these two functions. In part A of this question, we have a region R, which is bounded by the graph of g, the x-axis, the y-axis, and the vertical line x equals 1, and we are asked to find the area of region R. We get the integral from 0 to 1 of g of x dx, which is the integral from 0 to 1 of 14x plus 12 all over x plus 12. And since this is a calculator active question, we'll just use our calculator for this. That turns out to be 1.513. In part B of this question, we assume that R is the base of a solid and that cross sections taken perpendicular to the x-axis are rectangles where the height is 1/3 the length of the base. And we are asked to write an integral that would find the volume of this solid, but we do not need to evaluate it. This integral for the volume would be 1/3 times the integral from 0 to 1 of the square of the function g of x dx. In part C of this question, we are asked to find the area of the shaded region in the first of the two provided figures. Because the two curves do intersect in the middle of the interval, we are going to have to figure out where they intersect. The two curves that form the shaded region intersect at 1, 0, and again at the ordered pair A comma B, where A is 3.2558165 and B is 3.7743919. So we have to take the integral from 0 to 1 of f of x minus g of x dx, and then add that to the integral from 1 to a of g of x minus f of x dx. The integral from 0 to 1 of f of x minus g of x dx plus the integral from 1 to a of g of x minus f of x dx is 0.6317838111, which by FRQ rules, you could have either 0.631 or 0.632. Either of those would be acceptable. In part D of this question, we have a solid T, which is bounded by the curve x equals h of y, which is just a re-expression of the rational function. The y-axis, the horizontal line y equals 3.5, and we are asked to find the volume integral when this region is rotated around the y-axis. And again, we do not need to calculate the value of this integral. We just need to write the integral. The volume of this solid would be pi times the integral from 1 to 3.5 of the square of h of y dy. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.